want to talk about systems of equations. Systems of equations. And a linear system is really just two or more equations that we could draw on a graph. And the solution happens to be the point of intersection. So in that case, we see the point of intersection being 4, 1, 4, 1. Okay? There's three types of systems. The first system looks just like that, where there's an intersection, okay? And if you come up with an intersection, you're going to end up with an x equals of some sort. Say like x equals, in this case, x was equal to 4. But not all lines intersect. What kind of lines don't intersect? Parallel lines. So if you have a set of lines that look like that, they will not intersect. Well, what will the solution be when you have lines that don't intersect? The solution is going to be something like this. 4 equals negative 8. Is 4 equal to negative 8?
No.
No, it's not. And that's the indication that there is no solution. And then there's a third type. This one doesn't happen very often, but it does come up. You have one line, and then your second line is going to be right on top of that first line. How many times do those lines intersect?
Infinite.
An infinite number of times. So in this case, we have infinite solutions. Infinite solutions. And what that solution will look like, you won't get x equals 4, you'll get something like 4 equals 4. Or x equals x. You'll have the same thing on one side as you do on the other side, okay? So, you have the graphical piece, which makes a lot of sense. How does the algebra work out? That's kind of how it works out, okay? There's three ways of solving systems. The first one is by graphing. Does anybody remember another way to solve a system? Hint, starts with an S. Substitution, thank you. And the other one I'm thinking of starts with an E. Elimination. So we're going to practice those three pieces today, and then you're going to be able to work on that assignment and hopefully get a decent amount of that done. We only have one lesson after this we need to cover to be able to get to our test. So might be next week Friday that we test. Thursday or Friday. We'll see where we get to. First one we want to solve by graphing. Well, graphing, you guys are really good at that. I just take this equation, y equals x minus 2, and I'm just going to draw the graph. I go down 2, I go over 1, up 1. And I make my graph. The other graph is not in slope-intercept form, so you could place it into slope-intercept form if you so chose. Or if you don't want to place it in slope-intercept form, you could also graph it using intercepts. I really like using intercepts. I'm just going to show you how I do that. And if you didn't want to, that's fine, but I'm going to choose x to be 0 and y to be 0. That's something we practiced earlier this unit. Can somebody tell me if x is 0, what would y have to be?
3.
Yeah, it would have to be 3. You get 2y is 6, so y is 3. And suppose that you didn't have that. Suppose that you had y was equal to 0. So that would mean that this would kind of go away. What would x be?
6.
X would be 6. So notice you could graph that pretty quickly without turning into slope-intercept form. You just plot 3 on the y-axis, you plot 6 on the x-axis, and you draw your line. Now, one of the downsides of graphing is that, you don't always have, you don't have an exact spot sometimes. You can't calculate the exact spot where it crosses. Sometimes you have to estimate. I'm going to say it's like 3.1 for the x value and about 2.1 for the y value. Let me say that that's what you got. Okay.
What?
It looks like it's over 3 and, up 1.1, excuse me. Sorry about that. Probably focus.
I was confused.
Yeah. Okay, what I want you to do now is turn this into slope-intercept form, turn this one into slope-intercept form, and see if you can sketch those graphs and see if you can find out where they intersect, okay? Let's try that. Yeah, there you go. Solve for y, sketch the graph. Solve for y, sketch the graph. The double ring means it's coming from outside the school. So, could be my children. This is Mr. Gens. It's boost your business. You want to help boost my business.
Ah, so scared. Kind of.
I know I did, but go ahead and take some time, see if you can sketch a graph too. That's one more graph. That's one.
Yeah.
Okay, let's flip it over to the other side. Here again, it went through 1, 6. Those are in slope-intercept form now. We move on from graphing to substitution. Substitution. To substitute means you put something in place of something else. And substitution is really nice if you see an x equals or a y equals. So since this is x equals, I take this and I drop it right in for the x. And now I can do my algebra. So we're going to be able to find an exact value for the intersection point here. We have y is equal to, and it's 5 plus, I have the 1/2, but then instead of x, I place into there 2y minus 10. 2y minus 10. Notice how the x's are all gone, and now I just have one variable, I just have the y. So y is equal to 5. What's 1/2 of 2y?
Y.
Just y. And then it's 1/2 times negative 10 is negative 5. Hey, what do you notice happens?
It's y equals y.
Yeah, the 5's cancel, and I get y is equal to y. That's an interesting equation. Do you remember when we talked on the first page? If you get something equal to itself, what does that mean? Infinite solutions. They're the same line. For the next one, okay, you could take 3x plus 2, that's what y is equal to, and you drop it in for y. And so we get 3x minus 2 times 3x plus 2 is equal to -1. Hello.
Hello.
Where's the ball?
Welcome.
Where's the ball? Where's the ball? Yeah, where's
Oh,
the
that's
ball?
right. She does get the ball thrown at her, doesn't she? We will wait.
I had a band lesson. I'm not technically late.
I distribute the -2, and I get 3x minus 6x minus 4 is -1. Combine my x values together, I get a -3x minus 4 is -1. Add my 4 to both sides, -3x is +3. That means I have an x value of -1. If I have x equal to -1, how do I find the y value?
Plug it in.
Yeah, you can plug it into either one you want. I think it's easiest to just plug it in right here into the y equals. 3 times -1 is -3, plus 2 is -1. So my coordinate of intersection is -1, -1. So again, you need to have an x and a y value. The last step of solving systems is to use a process of elimination. Elimination makes the x's go away or the y's go away. And in this first example here, I'm going to ask Miss Carly, would you prefer to have the x's go away or the y's go away?
Why?
It is going to be nice for the y's to go away. Don't write this down, but if you added these together right now, you get a 13x minus 8y is equal to 12. Notice how when you add those, nothing disappears. If I want something to go away, I can't have a -4y on the bottom. I need a +4y. How will I change that to a +4y? Yeah, if you multiply the bottom through by a negative, we have 5x minus 4y is 0 on top. But on the bottom, I have a -8x, I have a +4y, and I have a -12. Now you can see that the y's are opposite in value. So now when you add them together, I get a -3x. Notice how the y's make 0, and I get a -12. Divide by -3, and x is -4. Not a great equation to use up here. I'm sorry, +4. Not a great equation to be able to plug back into. You could choose either one. I'm going to plug the 4 right into this first equation, and I get 20x minus 4y is equal to 0. Gosh, sorry about that. I'm distracted by those in the hallway right now. I thought I saw somebody being kind of naughty. So I get 20 minus 4y is equal to 0. As I subtract the 20, I get -4y is -20. And divide by -4, I get y is 5. So 4, 5 is your solution. Okay. This is the last problem we're going to do today is the 4x minus 3y is equal to 11. I want you to pair and share and talk with a friend about whether you want the x's to go away or the y's and how you'd make that happen. Okay, talk. How would you do it? Talk to the person next to you. How would you do it? Okay, somebody back here have an idea? What do you guys want to do? What do you want to make go away? The X's or the Y's? The Y's, okay? You could totally make the Y's go away. Do they go away right now? Did you have an idea how to make them go away? How? Good. And the bottom? Okay, so that way you would get a positive and a negative. That's a good idea. Anybody want to make the X's go away? No? Everybody just kind of went for the Y's? Okay, then let's focus on the Y's. It is correct that we would like one of these to be positive and one to be negative. But they can't just be positive and negative. We also need them to have the same number. So we want to say, what number do both the 3 and the 2 multiply to? 6. So I'll multiply the top through by 2, and that way I'll have a negative 6. 8x minus 6y is equal to 22. So I've got the top where I've got a negative 6y. The bottom, I don't want negative 6y, I want positive 6y. So as you guys said, we got to multiply that by a negative, but it's got to be a negative 3. That way I'm going to get that 6 there. So I get a negative 15x plus a 6y is equal to negative 36. I add them together and I get negative 7x. Notice how the 6y's go away just like I wanted them to, and that's equal to negative 14. If you divide by negative 7x is equal to positive 2. Got to find your second point, so you can take 2 and plug it back into one of these equations. I get 8 minus 3y is equal to 11. If I subtract my 8, I have negative 3y is equal to 3. So therefore y is equal to negative 1. So the coordinate 2, negative 1 is my solution. Suppose I wanted to check to see if that answer was correct. Anybody know what I would do to check to see if that answer was correct? Yeah, plug it into both of them. If it works for both, then it must be the solution for that system. So if you take out your homework, there's a couple problems I'm going to take off of your list that you don't have to do. We can see right now we are to linear systems of 2 variables. Okay. You do have a significant amount of time to work. You got about 20 minutes or more, okay, because we get out of here 11:32, which is a lot of time. The first 3, you want to sketch the graph and name the intersection point. And then for section 2, I say use substitution. And then for section 3, it says use elimination. If you look over on the next page for section 4, okay, for section 4, it says you choose the method that you want. You could just do 2 of those instead of all 4 of those. Okay? So you can cross 2 of those problems off that you don't want to do. You make your choice.
Of which one?
In section 4. Section 4. Okay? I'm going to grab the answer key and post it and give you guys some time to work. I'll come around and help and make sure you at least off to a good start.